Hey friends, Dr. Boroli is here. Today we will discuss about cathode ray oscilloscope. Cathode ray oscilloscope is a device which is used to display the waveforms of the signal connected to the inputs. Cathode ray oscilloscope, in short, also called as CRO, cathode ray oscilloscope. There are two types of oscilloscopes: simple dual trace analog oscilloscope and digital storage oscilloscope. The dual trace oscilloscope have two signal traces, means they can have facility to accept two input channel signals and display it on the screen. They uses analog processing circuit inside, and display is also capable of plotting the analog nature of the signal. Therefore, they are called as analog oscilloscope. These are probably the previous generation oscilloscope. Current generation oscilloscope are mostly digital oscilloscope, in which they accept the input signal on its channel and processes that signal digitally and displays normally on digital screen. Most of the time this digital screen is a LCD screen. Let us first see what is simple dual trace analog oscilloscope. If you see, the oscilloscope front panel is shown in this figure. Here there is a display area. This display can be done by using a cathode ray tube called picture tube, on which the signal will be traced. Shortly we will see how signal will be traced on the picture tube screen. Let us first concentrate on front panel appearance of cathode ray oscilloscope and understand the functionality. Here, the display screen area consists of graticles. Graticles are nothing but the graphical lines, similar to your XY graph. It is shown here in the second figure. X and Y axis are marked with major lines and minor lines. CRO is basically a YT instrument. That is, T is the variable T for time on the horizontal axis and amplitude on Y axis. This amplitude is probably the amplitude of the signal which is to be connected to the input of the oscilloscope. Normally, this input to the oscilloscope is a voltage. Therefore, the oscilloscope is basically a device which plots voltage versus time graph of the signal. And for measurement purpose, the graphical lines are provided. Major and minor graphical lines are provided for fine and coarse measurement. Here a typical waveform is shown in a figure. The distance measured on horizontal axis, that is the time axis, and therefore the measurement is done on horizontal axis is a time, whereas the distance measured on vertical axis is a voltage. We will see further how this measurement can be done. If you see the display section, there are three functions available additionally. One is intensity, another is focus, and a trace rotation. This intensity knob can provide you the facility to change the intensity of the waveform displayed. Focus knob provides you the functionality to change the sharpness of the waveform to be displayed, means sharper line can be displayed. Trace rotation is used to align the trace reference line with the horizontal graphical line. This rotation facility will allow you to change the trace position with respect to the horizontal line. Now, if you see, there are two inputs terminals. One is called channel 1 and another is called channel 2. In dual trace oscilloscope, the two input sections are required. Those are called as channels. Here input voltages are connected via a connecting probe. Normally this probe is a BNC connecting probe. The center terminal is positive and outer body of this connector is a common terminal. Right. According to every channel, there are some common controls present in the channel. Let us concentrate on a single channel. You will see here the external voltage connected to channel 1 connector. It is passed through a internal signal connection switch called as AC, DC and ground switch. When ground switch is pressed, the signal is internally grounded. So external signal will not reach to the internal input of oscilloscope. Rather, the input internally is connected to a zero potential called ground, and therefore a horizontal straight line will be displayed. There is another button AC and DC. AC and DC, this decides what type of coupling is used to couple the external signal to the internal input. DC coupling indicate that it is a direct coupling, means the input will be directly coupled through the switch to the internal circuitry. Whereas in AC coupling, the input signal will be passed through a blocking capacitor, so that DC part will be blocked and only AC part will be allowed to connect to the input of the oscilloscope circuitry. Now this signal is then connected to a internal attenuator circuit which provides us the various ranges of measurement. Here there is a knob volts per division. This volts per division knob provides us to scale the waveform on y-axis, means the amplitude to be displayed will be zoom in or zoom out by using the volts per division knob. Now there is a rotary position potentiometer called Y position. This Y position potentiometer can move the trace up or down, means Y position of the trace can be changed vertically. Similarly, if you see the second channel, similar controls are available for second channel. In multi-channel digital or analog scope, there are multiple such channel circuitry. If you see, there is another switch called as mode selector switch, in which there is a mode channel 1 or channel 2 or dual and add mode. Channel 1 mode is the mode in which only channel 1 signal will be displayed. Whenever mode is channel 2, then only channel 2 signal is displayed. Whenever the switch is in dual position, both the channel signals are displayed, means you get two waveforms on the screen. and add mode will be addition of the two channels will be displayed on the screen. Here if you see another section which is related to horizontal axis, that is the time axis. Here you will see a attenuator again or time per division selector. By changing this time per division selection position, you can expand or compress the waveform on the display. How the time and voltage will be measured, that we will see next. Whereas here there is a X position potentiometer. By changing this X position potentiometer position, we can move the trace horizontally. Whereas if you see the third section, there is a trigger section. Trigger section is very important section which is used to synchronize the plotting on the screen with respect to some reference point. And that reference point on the waveform will be decided by a level knob. By level knob, we can able to generate a trigger signal so that the waveform plotting will be started on the screen from that point. Here, the coupling is shown one of the selector switch, and source of trigger is also shown. The source for deriving the triggering signal can be channel 1 or channel 2. Or it can be a line triggering. Line triggering means main supply triggering. Or it can be a external triggering. For that purpose, we have to connect the external signal to the external input provided under the trigger section. Whereas there are two buttons, slope control and alternate triggering. This slope control that decides whether the triggering is done on positive slope or negative slope. And alternate triggering will be the triggering can be synchronizing the waveform from the two channels. I think this will show most of the controls. Now let us see how the various parameter can be measured on the oscilloscope screen and how their values will be decided. Amplitude, time and frequency measurement is shown here in the figure. A typical sinusoidal waveform is shown with a graphical screen and there is a graph line plotted. The major and minor vertical lines are there. So for measurement of amplitude, first we will measure the distance from the reference point vertically to the peak of the signal. Then this distance in terms of number of divisions is multiplied by the volts per division setting. That will give you the peak value of the voltage. Here one division corresponds to how much volts that will be set by volts per division. So therefore, the vertical distance on y-axis or vertical axis, more correctly the voltage axis, into the volts per division setting gives you the voltage value between the 2 points. If the voltage measured between reference and the maximum value, then it is a peak voltage. If we measure the distance from lowest peak value and negative peak value and positive peak value voltage, then it is peak to peak voltage. If you want to measure the time, then we can measure the time between two zero crossing occurs in a cycle, and that will be the time period. Here we will measure the number of division horizontally, including subdivisions also. You can see here in this waveform, here this is one division, this is second, this will be third, and this will be four divisions, four major divisions. Then 4 into time per division setting gives the total time between the starting point and end point, that is the cycle time period. Here one division is divided in 5 sections, means each subdivision is of 0.2. So if the waveform is more than one division, the subdivisions are also used to count precisely the time on x-axis. So time is equal to number of horizontal divisions into time per division. Setting of the time per division now. The phase shift can be measured by using the difference between the two reference points. For example, here first signal is at 90 degree and second signal is at 0 degree. So if we check the zero crossing of the two signals, the difference, time difference between the two zero crossing is related to the phase angle phi. Phase angle phi is equal to omega into t. Here by using oscilloscope, we will measure the time between the two zero crossing points. Multiply it by the time per division setting, that gives you the time difference. When that time difference is multiplied by omega, that gives you the phase angle phi between the two signals. Similarly, the frequency can be measured by taking the reciprocal of the time period of the waveform. Let us see the block diagram of a CRO. CRO consists of a picture tube called as CRT. This CRT consists of a cathode, a focusing anode system that is not shown here, but it will be detailed in the next diagram, the vertical deflection system and horizontal deflection system. And on the far end, there is a screen. This is basically a glass surface on which phosphorus coating is applied. And the property of this phosphorus is whenever the electron strike on the phosphor with a kinetic energy, it will give the kinetic energy to the phosphorus atom, and that phosphorus atom now emits the photons, and therefore we will see a light on the screen. We will see the detailed operation of CRT in the next topic. Here, if you see the circuit block diagram, the input signal is applied via the channel connection to a vertical amplifier. Vertical amplifier function is to amplify the input signal amplitude, and this vertical amplifier basically provides us the facility of volts per division setting. The output of vertical amplifier via delay line is connected to the vertical plates. This vertical plate voltage is capable of deflecting the electron beam vertically. Similarly, from the signal output available from vertical amplifier, the trigger circuitry establishes the trigger point on the waveform. So the function of the trigger circuitry is to generate a trigger signal by comparing a voltage output available from vertical amplifier with some standard reference. which is adjustable by level control. Then the trigger signal generated, that will trigger the time-based generator. Time-based generator is basically a ramp generator which will linearly ramping up and then reset back to zero. Again ramping up and reset back to zero. This time-based generator is amplified by a horizontal amplifier, and the output of horizontal amplifier is connected to horizontal plates of the CRT. This voltage from the horizontal amplifier is capable of deflecting the beam horizontally. Horizontal amplifier provides us the facility of time per division. The gain control of horizontal amplifier decides the time per division to be measured on the CRO screen. The vertical amplifier or vertical deflection system and horizontal deflection system in combination is capable of moving the electron beam horizontally and vertically in proportion to the voltage applied to vertical plates and horizontal plate, and thus it will trace the signal on the screen of the oscilloscope. The various blocks those are present in the oscilloscope that are shown in the block diagram are listed here. That can be a vertical amplifier, trigger circuit, time-based generator, horizontal amplifier, and cathode ray tube. We have discussed the functions of these blocks already. Let us see what is cathode ray tube look like somewhat more in detail. Cathode ray tube is basically a vacuum tube in which there is a thermionic cathode. This cathode is heated with a heater, and the cathode is coated with a special thermionic material. So when the cathode is getting heated, it emits the electrons. Then it will be surrounded by the control grid. The function of the control grid is to control the amount of electron those are moving from cathode to the anode. Anode, here there are three anodes present. One is the screen which is placed at highest positive potential, so that acts as an anode. And in between there are two anodes. One is called accelerating anode and second is called as focusing anode. Those are placed at the positive potential. Now the electron generated after emission, those are passing through the control grid, is attracted towards the accelerating anode, and due to that they get acceleration. They are further passed through focusing anode that will create a condensed beam, means the spread of the electron beam will be now reduced by the additional potential of the focusing anode, which creates basically an electric field, and that will deflects the electrons toward the center position, so that sharp beam will be created. This beam is then passed through the two horizontal and vertical plates, deflection plates. The voltage applied to these horizontal deflection plates moves the beam from left to right on the screen, and vertical deflection plate moves the voltage vertically on the screen. So here in the figure, the another picture tube is shown. Instead of direct voltage connection to the vertical and horizontal plates, here vertical and horizontal plates are replaced by a magnetic deflection system, in which the magnetic field will deflect the beam vertically and horizontally. The vertical amplifier feeds the vertical deflection plates. The vertical amplifier controls the display amplitude, that is the deflection on y-axis. It provides the amplification and attenuation to the input signal. It provides us the facility of volts per division on the screen. The built-in attenuator that provides us volts per division selector, and it also provides the basic high input impedance to the channel. The triggered time base generates a triangular sweep signal which will sweep the cathode ray beam from left to right, and then again the signal will be resetted back and again trace the signal from left to right. How the oscilloscope displays the waveform that is shown here. You will see here, this is the screen of CRT. This is the y-axis signal and this is the triangular x-axis signal, that is from horizontal time base. The ramp signal here is also called as time base signal, that is shown here. The time axis is vertically shown and the voltage axis of the time base signal is shown by Vx. Now if you see the waveform, how it is getting plotted, consider point A. Point A is here and corresponding the vertical position on the screen is shown here. At that time, the horizontal position is given by A point on the time base. Now, whenever the input signal changes to B point, that time the triangular wave signal or ramp signal also reaches to B point, and therefore the signal will be tracing the point B. In between A and B, the continuous signal will be traced. The same point locus available in the input signal is traced on the oscilloscope screen. As we go on changing the signal from B to C, again the amplitude or deflection of the beam will be coming back to the reference point, whereas the x position is moving from this A corner to C point, and therefore that point is here. So just project this point C here on the screen and this C point vertically. The cross section of the two line gives the C point. Now whenever input reaches to the D point voltage, then the vertically the beam will be deflected by this much distance. So just plot this and extend this on the screen. Similarly, extend the line from D point on the time base waveform vertically. The crossing point will be the D point. So if you consider complete A, B, C, D, E, F, G signal points, you will get the time base is moving also from A to G, and you will see the beam will be continuously pulled vertically by the voltage connected to the vertical axis, that is input, and it will be horizontally pulled by the time base generator. This can be shown how it is happening in this video. Let us see. Here this cathode generates a beam and the focusing anodes create a sharp beam, whereas voltage connected to horizontal plates moves the beam horizontally here, and the voltage connected to Y plates deflects the beam vertically. And since the voltage connected to vertical deflection plates are changing sinusoidally and voltage connected to horizontal plates in the ramp fashion, the beam will be moved on the screen in vertical direction as per the signal amplitude and from left to right due to the time base generator. And this way, any waveform can be traced on the screen. This is all analog oscilloscope. Digital oscilloscope or digital storage oscilloscope is similar, but the processing of the external signal to be measured is done by processing via digital circuit, and floating is done on the LCD screen, which is different than the CRT based display system. Normally, the display used in the digital storage scope is a LCD display. If you see, there are multiple channels. Here, two channels are shown. This oscilloscope is made by a company, Textronics. There are two channels, channel 1 and channel 2. As usual, there is a selector for volts per division for channel 1 and volts per division for channel 2. There is a position adjusting potentiometers for the traces. The trace can be adjusted on the screen vertically by using the corresponding position control potentiometers. Here again horizontal control section is there. Here as usual there is a time per division selector switch, and again horizontal waveform position adjusting potentiometer. The trigger section is as usual, which generates the trigger for synchronization of the floating of the waveform. In addition to that, there are multi-purpose functions available. Here you can have a cursor button which will turn on horizontal and vertical cursors here, and you can able to do the measurement on x-axis and y-axis using this cursor. The readings of the cursors are directly displayed on the CRT screen itself. There is no need to measure the number of divisions on vertical axis or horizontal axis and then multiplied by volts per division or time per division. Direct metering can be done by doing the measurement by the internal circuitry and displayed here directly the channel 1 and channel 2 voltages. Here, in addition to that, in storage oscilloscope, there is a facility to store the waveform. This button save and recall is used for that purpose. If you want to store the waveform, you have to first acquire the waveform, and then once the waveform is acquired, you can store it by using save button. Save button provides you the facility to save that recorded waveform in the internal memory of the oscilloscope. It can be anytime recall by using recall function, and it will display the waveform which was stored. There is additional button function. This button when pressed, there is a menu appear here, and that menu provides you many facilities so that you can measure the voltage, which is a peak voltage, which can be average value of the signal, and so on. Whereas on x-axis, the functions are available to measure the time period, to measure the delta t values, and so on. So many functions are available. You can able to measure the rise time and fall time of the waveform also. And these function can be selected by using the selector switches present on the panel. That is going via function selection. There are utility menu in which many utility functions are there. So storage scope and ordinary digital scope, a major difference is that in digital storage scope, there is a facility to store the waveform starting from some trigger point, so that we can able to record the non-repeating occurrence of the signal values. The basic block diagram of A digital storage scope is shown here. In this diagram, input is connected to, as usual, the vertical amplifier through a attenuator. The attenuator provides us the functions of voltage per division. The output of the attenuator is given to analog to digital converter. The function of analog to digital converter is to convert the analog signal from the amplifier to corresponding digital value. ADC is basically a digitizer, and these digital values are stored in the memory. Means your signal will be sampled and stored sequentially in many memory locations, and the signal is now available in the memory. If your display system is analog in nature, that is using CRT, then it have horizontal plates and vertical plates. These are driven by vertical amplifier and horizontal amplifier. Vertical amplifier gets the input from the input channel, whereas here we get the signal which is digital in nature. So it should be converted back to analog signal using digital to analog converter. And then this analog signal is now given to the vertical amplifier that deflects the beam of CRT vertically. Whereas horizontal amplifier is feed from time-based generator. This time-based generator generates the ramp signal that is connected to horizontal amplifier to the horizontal plate. That will pull the beam from left side to right side. So whenever the beam is pulled vertically by the signal, say sinusoidal signal, and if it is pulled horizontally linearly from left to right, then sinusoidal signal will be traced on the CRT screen. The trigger circuit generates the synchronization pulses to synchronize the time-based generator. In digital storage scope, compared to your analog oscilloscope, the signal will be first converted to digital signal and then it will be stored in the memory so that the recorded signal can be anytime recalled and displayed for analysis purpose. The function of time-based generator is to pull the electron beam from left to right linearly, whereas the vertical amplifier function is to amplify the y-axis signal so that it will move the beam, deflect the beam from bottom to top. Vertical amplifier as usual provides a voltage per division selection, and horizontal amplifier gain control provides us the time per division selection. So this is in short the storage oscilloscope. The reconstructions and other details of the waveform by using digital storage scope is beyond the scope of this subject and therefore skip off. Today we will stop here. Till then, bye bye.